Hello? Okay, so good morning, everyone. Let's start our class today. And today we are going to talk about two libraries in Python. One is pandas, one is matplotlib. And these are two libraries that you might frequently use in this course in the early future. And so firstly, please download the files for this lab today, Lab02 in the OLE. And then in this file, you have, in this document, you have three files. One is the Python notebook file that you are going to do coding on it. And another is a CSV file and also an image here. So let's first open the collab. So yeah, just in case you forgot how to use this collab. So as you've already have a file, you just need to upload this notebook with upload here. And then you can browse your computer or just drag your file inside this window. Then it will open a new notebook for you. And there's some updation that you can ignore here. And so yeah, here's the blocks of codes. And you can click here to upload some other files that you might use in these codes. So usually you have two ways to upload file. The first one is that you directly upload here in this workspace. But the problem here is that anytime you close this window or you quit the collab, then the files will disappear the next time. And another way is that you just mount your Google Drive in this collab. And then the files you can upload to your Google Drive and then read it every time when you are using this notebook. And for this Google Drive, you can try later. And in the class, we just use to upload the file in the workspace here. So we have the two files. One is the CSV file. Open it. And then another one is the image. Yeah, so you should upload the two files here for later use. Okay, then any problems here? No, then let's move on to the main content. So yeah, the first part of this lab is about matplotlib. So it's a powerful lab in Python for you to plot different kind of charts. So you can refer to the documentation here by this link actually. So there will be some examples and some cheat sheet that you can refer for beginners. There's some explanation of the codes, but doesn't matter. Nowadays you have ChatGPT, so you can just ask ChatGPT like how to use a certain kind of functions. So it's not a problem. And okay, so let's start to look at the code here. We go through the code together. So firstly, is the simple function of plot, PLT. So we just import this lab here. And also, because we might use some arrays here, we also import this NumPy we learned from last class. Okay, then we define some values. And like the x-axis and the y-axis. I mean, the values on x-axis and y-axis. Then we can okay. Yeah. So then we have x values here, right? And we can correlate these two values. One is the function sin x, another is this variable x. So we put the relationship between x and the sin x according to the solution and the resolution we put here. So the resolution is actually 1. You can see this plotting is quite rough. You cannot even see the shape of sine curve. But it's too far of some. Okay, yeah, but we have a better solution here. Okay, so we can use we can redefine the x. So we can use a function in NumPy about linear space. Like we can define the start point and the end point of the x-axis and its resolution. So let's see. First try. We start at 0 and stop at 4 pi. So this numpy.py is the pi value that you can get from the NumPy library. And in total, we can put like 100 dots, 100 points between this linear space. So the more points you put here, the higher resolution you'll get. So then we can have a look at it together. So then it will be more like a sine curve, sine wave. And you can also change the resolution. So if you only put 10, then it still looks like nothing. But if you put higher resolution, it will be more like the function you put here. So this is how we use this linear space. Or we say link space here. And also, you can give some labels and titles in this matplotlib for plotting. So let's say we can put the label as x. So we use a string to define the label. And then also like for the y values, we can define it as sin x, just for some information for the users or some other guys who is looking at your plots. And we can also give a title about the plotting. Let's say this title is sine function. Okay, and y limitation we can define by ourselves, but it doesn't matter. So you can put like because the range is from -1 to 1, so we can put maybe -1.5 to 1.5. Okay, and then you can also set the grade. If you want here, yeah, grade. If you want to show grade of each axis in the graph, and then we can have a look at it again. And yeah, so we should put the code here. So we should plot the chart first, and then set the parameters of this chart. Yeah, and then to be like this. So these are the grades for the two axes, and we have the notation of the y-axis and x-axis. Yeah, and if you put this as false, then the grid will disappear. It will be blank. And also you can flexibly modify the limitation of the y-axis, like -1 to 1, doesn't matter. Yeah. Yeah, this is how you define the parameters of this plotting, the line chart. Okay. And also we can add the legend. So legend means the information about the curves, what the curve means, or the name of this curve. So we can just actually copy paste the code here. Oh, no, we have two plots. Okay, so X label, Y label, we just give some random name. X label is X, Y label is we have two values, so it can be sine X and cosine X. Now we are plotting two curves here together. Cosine X. Okay, so it's just a name of the label of the y-axis. Doesn't matter what you give. And also give a title. Okay, like sine and cosine functions. Okay, then we just use this building function in the matplotlib, which is legend. Yeah, it will pop up by itself. So yeah, so the difference here is that a legend of these two curves will appear here, showing that which color represents for sine wave and which color represents for the sine wave. Yeah, and so the legend, the name of the legends of each curve is defined here. That you can put a label here. Right? For example, you can put only, okay, and then the name in the legend will change to what you define here. Yeah, and also you can define the color here. So here, R means red, B means blue. So you can also use like green, G. I think it is G. Yeah, something like this. So for some other specific colors, you can just check how to use this function on the internet to see which color represent by which character. There'll be a lot of choice. And okay, then let's talk about any problems here. Yeah, so for the student just came, please I just want to give you some remind that you should upload your files here, okay? So we have two files today. One is the JPG image file. One is the CSV file for the data. And for other files, you can download in the OLE. It is in a zip file of Lab02. And okay, then let's keep going. Talking about this subplot. So yeah, we plot these two figures first. This is then we can use subplot functions. That's changed. Okay, doesn't matter. So we can change the plot. X label, Y label, title. We can plot them into two different subplots. Okay, so just delete this one. LT subplot. Use this subplot function. And in this subplot function, we can define like how many rows and how many columns and how many rows we have. So for example, these three arguments here means we want one column in the subplot and two rows. One row. The first one is the row. So one row in the subplot, two columns, and this figure will be plot on the first place. Yeah, and then we put the subplot again. So let's say we have two figures. We want to put these two waves into different subplots. So we can put another one in the second place. And then the output will be like this. Yeah, in this way. So we have two separate plots in one figure. And we can see if we change it to like 2, 1, 2, 2, 1, 1, and 2, 1, 2, what will it be like? So it will be like two columns. Oh, sorry, two rows. The first one is the rows. The second one is columns. So in this way, we have two rows parallelly and one column. So we can also change the numbers here. If we want to put the cosine wave on the first place and sine wave in the second place, and then the order of them will be changed. So we will plot the cosine first and then the sine wave. This is how we use this plot. And if you have more figures, then you can, let me just copy paste the things here. Okay, so let's say we want to plot 4 figures. And then we need to define the rows and columns. So we may need 2 columns and 2 rows. Okay, and then each subplot we should put in a certain place of these columns and rows. So it will be a 2 by 2 plotting. So we have 4 in total. And the first sine wave we put in the first place of these 4 plots. And then 1, 2, 3, 4 each place. Yeah, so this is how we use subplot. And yeah, so being presentation is like this. Yeah, so you define a subplot and plot the function and set the labels and title for each subplot. Okay. Then let's look at histograms. So histogram is a very useful plotting that you might use to analyze your data, like to see the distribution of your data. I should change all this into. So let's just plot a figure here. And the figure that it asks us to put a figure size, big size, big size. 4 by 6 as defined here. Okay, and that's us to, we should plot two different figures. Okay, we put in a vertical way. So we have two rows. And then let's do the plot. Like y. Y is the some random data we created by the normal function here. This means create a data of normal distribution. Okay, so I think everyone here knows what is normal distribution, right? And then, so in this way, the data should be in the range from 50 to 10. Sorry. Sorry. Yeah, this is the mean and the variance. So we should have a mean value of 50. Sorry. Yeah, this is how we define a normal distribution. So we have a mean value of 50 and the standard deviation of 10. And in total, we plot 1,000 points. And then we plot its histogram of this y. So we can also define the bins. So I will tell later what is bins. So, okay, so this the result. So this 20 means bin. Bin means here it's like the interval that we put here. So it's like if we define it at 20, then the interval will be, so in total we will have like a 20 bar plot here. So it also set the interval of this bar plot. And then if we put less bins here, then we will have less resolution. For example, if we only put 10, then it will be like this. We change the resolution. Yeah. So we can set to a proper value. You can see it follows a normal distribution curve. And these are the something like a white noise. So, white noise is following normal distribution. And in total, we have 1,000 points here. Yeah, this is how we use this histogram. So later, when you're doing a project, you might want to check like the distribution of the data you use or the data you collected by yourself. Then you can use the histogram to have an overview, like how the data looks like. Yeah. And then let's see how to display a figure. So we just need to use the image rate in the matplotlib library. So we just need to put the name of the image here. And this is our logo, right? Because copy paste the file name and then put it here. Okay, then we shoot image here and put the axis. We can set this. We don't need axis. We just want to see the figure. Logo mean, right? Yeah. Oh, sorry. I need to put the name. This should be a string. Yeah. So then we can see the logo here. And actually, our image is put in the folder, right? Image folder. And you can also just put the whole folder here. You cannot, but you can create a new folder here. Okay, let's say we create a new folder here, image. Yeah, and then we upload the image into this new folder. Then we just need to change the folder name here to put the directory of this image. Then it will be the same. Okay, but if now you delete the file here, then if you want directly get the file from this folder, you cannot because you put in another folder. So you need to put the whole directory. Didn't say right. Oh, oh, sorry. I put the wrong slash. Yeah, so it's like this. Okay, then let's talk about pandas. So again, you can refer to the libraries in this link, from this link, okay? So pandas is usually used for when we want to deal with our Excel or CSV files. And it will be something like a 2D table of data. So it will have rows and columns with their names. So we can first have a simple look at the example here. And we defined a data frame by ourselves. So how we define data frame is that we define the tables column by column. So we can just print this data frame df. Okay. And then you will see something like similar with the table. So these are the columns and the rows. So this is 1, 0, 1, 2, 3, 4 are the index. And we have the columns that we defined. Like this one, this means how many samples or how many instances we have for each column. And we have 3 columns here. And also you can just put df here. You don't need to use print actually. And then it will print an object like a table. So when you use print, it will only print the data inside. But when you directly use this df that you defined here, the data framework. Okay, so let's put df here to see it clearly. Then it will be a table. Okay. And also, as we defined here, the data frame here, we can also read the data frame from the CSV file. Let's first save this data frame. Let's say df to CSV. Wait, then yeah, so it will pop up to CSV. So this is how you save a data frame to a CSV file. Okay, and we can use this function to save the data frame you got from Python. Then let's say we save it as pandas data. Pandas data. And we need to put the extension here, CSV. Okay. Oh, let's put it like pandas data 2 already, because we already have one here. Okay. And then if we want to open this file, we can use this command with open. And then we put the name of this file. Okay. And then we import it as a file and just print the file. Just read the file. Yeah, use the file read. Then, yeah, this is one thing I think. Yeah, so this is one way to read this file. And also we have another way that we use the function from the pandas library. So we can define df equal to pd dot. We use this function read CSV because we have two CSV. So I mean, to save a CSV, we use two CSV, but to read the CSV, we use this read CSV function, CSV. And okay, put the name again. Yep. Then we just try to print out. So yeah, then it will be like this. And also here you can see without the index. So because you can see like when we print the read value of the file, we have this 0, 1, 2, 3. So this might be a bit annoying. So you can set like index equal to false when you are saving this pandas file. Then it will be like this. Okay. But if you are trying to read this file by this, read CSV function, the index will be still here because the internal parameter of this data frame itself. Yeah. We can also read like the file we uploaded by ourselves. So it's like this. This is the file we uploaded by ourselves, right? This is the one we created. So you can, if you have some CSV files that you download from some other sources, you can just put it here and then read it. Use this read CSV file. Okay, and then you can also change it to NumPy arrays kind of things. I think the code should be like, let's see, array. Okay, put the AR equal to NumPy dot array. Dot array. Yeah. Yeah. So we can change the data frame to an array with NumPy array. So after that, in your machine learning algorithms, usually you will deal with arrays rather than data frame. So sometimes you can firstly import it as a data frame and then convert it into a array. Sorry. Yeah. Okay. Then there are also some function to see the attributes of the data frame. Yeah. So let's see. We want to see the index. So the index is the 0 to 3 here. Okay. So this means the index. Let's see what's the index we have in this data frame. We can use this df.index. And also, like we want to see how many columns and what's the name of columns. Then we can check the columns right here. So you just need to put a dot and then to automatically pop up. And then shape, the shape of the data frame. Shape of data frame. And shape. Yeah. shape of data frame, and then the data type. Data frame. Yeah. Yeah. So we can see we have the index. It starts from 0, stop at 4. So again, I want to emphasize here in Python, usually the stop part is the open interval. Okay. The start part is the closed interval. So when you see it stop at 4, it means no 4 is contained here. Okay. There are only 0, 1, 2, 3. And the step is 0 at the interval for each step is 0. And like the columns, we have 3 columns, and the names of them are like this. And the shape of this data frame is 4 by 3, apparently. And data type. So, okay, so one thing here is that if one column, you only have strings here, then the data type of this column will be an object. Okay, and like if it only have numbers here, then the data type can be like integer or floats, anything. But once it has string, then it will be the data type will be object. Yeah, and also you can just use a simple line, data frame information, to get the information of the data frame. Then let's talk about this head and tail. So it's like we want to plot like only a small part of the data frame. The head means the data at the beginning. So let's say we want to have the first 2 datas. And also the last 2 data. Tail means the data at the end. Then it will be like this. The first 2 data from the data frame, and then the last 2 data from the data frame. Yeah. And then we can also print the series. Series means a colon in a data frame. Okay. So let's see if we just want to have a single series. Series. So we just use this data frame. We use a bracket. This engage, right? We use a square bracket here, and then we put the column name H. Okay, then here we can check the type of this S, and we print S. So then it will be like this. Okay, sorry. Oh yeah. This actually H. H. Actually, this doesn't matter. That's why I'm using this one. H. Because yeah, it's in upper class. H. Yeah, so we can see we plot the single column of H from the data frame. And the type of this column we define as series. Okay, we can also use some other functions to check like some statistics of the data frame. For example, let's use this H column again. Okay, and then we can print like the mean value. The mean value and the max value and the mean value. Yeah, sorry. Mean. This one is minimum, one is the mean. Okay. minimum, maximum, and the mean value. Okay, we comment this line again. So we can see like the minimum, the minimum, the maximum value in this column. It should be 10 and 15, right? And the average is 12.25. Okay, but we also have a better way to get this kind of statistics. We can use a function called describe. Yeah, so it will pop up by himself. Dot describe. It's a function inside the data frame library. Then it will give you all, a lot of kinds of statistics of the data in the data frame, like how many data you have, like the mean, the average, the standard deviation, the minimum value, and the 25%. This is used in the box plot, if you know. So like the first 25%, the first 50%, the first 70%, 75%, sorry, and then the max. These values you can use in the bar plot, box plot. Yeah, you can use this to see the statistics of the data frame. And also you can use a function called group by. Yeah. So we can sort them by groups. Let's see. We want to have two categories based on the gender, sex. Then we use this describe function again. It will give you the statistics of two groups according to the sex. So it's like female and male. We have two female in this data frame, two male in this data frame, and the mean value, the average average age of these females and average age of these males, and all other statistics. You can use the columns data to group the data in the data frame and then get the statistics separately. Okay, yeah. And the last one is to plot the data with data frame. So it's very easy. It has a function inside this library. Just use this plot. And you can plot, like, choose a column. For example, we choose a column of name. Then it will automatically calculate the set the name as x-axis and then the age as the y-axis. Why? Because we only have numerical data of age here. That's why it only have one line here. So we can also define more specifically, like the y value should be equal to the age. Yeah. And if you didn't define the value of y here, and if there are several columns that has numerical data, then it will print all of them together. So this is how you use this plot here. Okay, so I think we still have too many content in this step. Yeah, but these are some basics. When we start the machine learning part, I think it will be better. Okay, so now, you might don't have time to do it here. So, but we have some exercise for you. You have two questions based on the code here. Yeah, I will save this file and send you, okay? So you can refer to other code that I put here to finish your work of your exercises in case that you don't have time to put this code. Yeah, and so the deadline of this assignment is 5th of February. And as I've told you in the lecture that I will only check 5 of you each time. So yeah, so you can, of course, I don't suggest you to submit an empty file, okay? Because if you are fun, then you'll get 0 score in the assignment. But yeah, the point is that I only check 5 of you for each lab randomly. So it's better that you still do all the things here, just like have a revision of this class. Okay, so any questions here regarding the assignments? Okay, if no, then it's the end of this class, and I will save this file and send in the OLE for your reference. Thank you very much. Export it. Export, where export? Download. Yeah, download this thing. Let's see. Wait. Yeah, so yeah, this is the file with answer. I will upload on OLE for your reference, just in case you didn't follow this step. Okay. And like if you haven't picked attendance, you can pick attendance here. Yeah, so now you can download this file with answers here. And you need to finish the exercises part by yourself. Okay. So thank you very much. And it's the end of this class. See you next week.